Welcome back, my students. We are in Algebra 2. We're on lesson 38. We're going to talk about the power of sums. We know that when we have a number like this, x squared, and it's squared, that it really equals x to the fourth. Because what we're doing is x squared times x squared, and we know that we add these two together, and that becomes x to the fourth. So the shortcut is just to multiply the exponents to get the result. And we know that that also works when we have a number like this, and we cube it. We know that we cube, these are all factors, so we know we cube everything in here. So everything would just be multiplied by whatever the exponent is that it has. So that would be 6, this would be 9, and this would be 15. We know that to be true because these are all factors of one another, and raising it to another root or another power is the way we solve that is by multiplying the exponents, just like we did up here. However, we cannot do that when we have an operation. So for instance, if I had 3x squared plus 4 squared, I could not square each individual thing and have that be the right answer. It does not work that way. I couldn't say 3 squared x to the fourth plus 4 squared, because then that would be 9x to the fourth plus 16. Right? If we use that logic, this is what we would have. But that is not what we would have. In actuality, this is going to be 3x squared plus 4 times 3x squared plus 4. And we would have to do some distribution. So 3x squared times 3x squared would be 9x to the fourth, right? 3x squared times 4 would be plus 12x squared. And then again, 12x squared, because we would take this number times this number. And then we would add 16. And so we would actually end up with 9x to the fourth plus 24x squared plus 16. So you see, we can't apply that when we have an operation because we have more than one term to deal with. We have two terms that have to be distributed to two terms. So it's a little bit more of an involved process when you have an operation. So bearing that in mind, we are going to look at example 38.1. So let us write that out. 38.1 is x plus 3, and this is cubed. So we're going to write that out. First, we're going to do x plus 3 times x plus 3 first. So then we have x squared, if I can get it to square, plus 3x. And then we have another 3x, and then we have plus 9. We add all that together, we get x squared plus 6x plus 9. And now we still have another x plus 3 to multiply, and that should be a 9 there. So we do it again. X squared times x is going to be x cubed plus 6x squared plus 9x. And now we do the 3 times 3x squared, so it's going to be 3x squared plus 18x plus 27. And then we combine everything. So you can see it's a little bit more complicated than just, if we were to take this and just apply it the way we normally would, we would have had x cubed plus 27. And that's just not what this number is. We're totally missing out on these two middle terms. So that's wrong. And this is correct right here. All right, so now we're going to learn about, or talk a little bit more about, solving by factoring. Sometimes we just can't get, we can't solve for something. We have to set it equal to something else in order to solve for it. And that something else is 0. And we know that if a product of two factors equals 0, then one of the factors has to be 0. Like, for instance, if we have 4 times some number and that equals 0, well, this factor has to be 0. That's the only possible correct entry for that set of parentheses, or for that variable. In the same way, if we have an indicated multiplication where we have two factors here, and we set them equal to 0, one of these has to be 0. Either the first one or the second one has to equal 0. And it's so important, this fact is, that we gave it a name. It's called the zero factor theorem. And it states that if P and Q are real numbers, and P times Q, it's supposed to be a Q, not a G, and Q equals 0, then P or Q must equal 0. All right, or both, or both. One or the other, or both of them have to equal 0. So whenever we can't solve, and usually it's a trinomial where we have x squared, we factor our trinomial, set it to 0, and then we figure out, okay, if this one is 0, what is this value? If this one is 0, what is this value? And then we try them out. We test them to see which one is correct. All right, so let's try 38.2 using that method. So we have negative x plus x squared equals 6. So first of all, we have to set this equal to 0. So negative x plus x squared minus 6 equals 0. And we got minus 6 because we subtracted 6 from both sides. Now we need to write this in degree format, or in the descending order of degree. So it's going to be x squared minus x minus 6 equals 0. And we do that so we can factor more readily. So now we put our parenthesis out, and we have our x times x, which gives us x squared. And now we look at negative 6, and we say, okay, in order to get negative 6, I need to have a negative and a positive number, and when they combine, I need to have a negative 1 left over. So it's going to be negative 3, positive 2, because when you combine negative 3, positive 2, we have a negative 1 left over. So this is the correct factorization for this trinomial. So now, just like over here, we don't know which one of these is equal to 0. So we're going to test them both. We're going to say x minus 3 equals 0. And we're going to say x plus 2 equals 0. So x is either equal to 3 or x is equal to negative 2. So now we're going to test and see which one is which. So first, we try if x. So we use our trinomial, not trinomial, we use our original equation, and we see if we can solve for it. So let's put in negative 3 plus 3 squared equals 6. So negative 3 plus 9, and that does equal 6. So that is correct. So now we're going to try negative 2. So a negative 2 is a positive 2 plus 2 squared. So a positive 2 plus 4 does equal 6. So that checks. So both of these are correct. So x equals 3 and negative 2. Note that is the solution set for that problem. And technically we don't write it. I don't know why I wrote it like that. Technically we don't write it in parentheses. You can just write x equals 3 comma negative 2. When you type it into Jupyter Ed, just write this part here, 3 comma negative 2. And I may even have blanks where you could put in all the options. Now let's do 38.3. It's the same type of problem, and I'm going to let you solve it yourself. So let me type it in. All right, so here is our problem. We have negative 35x equals negative 2x squared minus x cubed. So I want you to put on your thinking caps and think about how to factor this problem such that you can set it all equal to 0 and solve for x using the zero factor theorem. All right, so go ahead and pause, solve the problem, and then press play in order to see if you got the answers right. All right, my students, for 38.3, we factored. First, we had to put our trinomial in standard format. Then, noticing we had a third degree trinomial, we factored out an x here because we had an x in each one of our terms here. Then we factored the trinomial into two binomials. So we ended up with x times x minus 5 times x plus 7, which meant we had 1, 2, 3 factors that could be 0. So the first one, of course, is x equals 0. It's just by itself. 0 times any of this could have been 0. Then we had x minus 5. When we added 5 to both sides, we got x equals 5. And then when we subtracted 7 on both sides, we got x equals negative 7. So these are our options. So then we set to check them. So obviously, if we put in 0 for x, x times all three of those would be 0 times 0. Or 0 equals 0, so that checks. So then we checked our 5, and we got negative 175 equals negative 175, so that checks. So then we tried our negative 7, and we did the multiplication, and 245 equals 245 when we did all the math. So that one checks. So x could be 0, 5, or negative 7 for this problem. So if you got 0, 5, or negative 7 as your solutions for this problem, then you are correct. All right, let's move on to only 0 equals 0. This is the third part and the final part of this lesson. If we solve the following two equations by factoring, and let me clear the page so I can give you the following two equations. We have x3 plus 2x squared minus 35x equals 0, which I believe is pretty close to what we had up here. Yeah, it was the same one we had just recently. And then we have this one. Right? What do we see? The results of the factoring are similar. We see some similarities between the two of these. We see that the factors here are just like in the problem we did recently, x minus 5, and x plus 7. And we see that the factors here would be 2 times x minus 5 and x plus 7. Right? In both cases, we have the product of three factors equal to 0. It would appear to some that each equation has three roots. In A, we can see, we can set each set of the factors equal to 0 and find the solutions are 0, 5, and negative 7, which we did. Equation B is different because although it has three factors, only two of the factors can ever be equal to 0. X minus 5 and x plus 7 are the only ones that we can equal to 0 because 2, the factor 2, can never be set to 0. So 2 only equals the number 2. So do not make the mistake of trying to turn this into a 0. The easiest way to look at it is that the only factors that you can set to 0, only factors are the factors that you can set to 0 or that can be set are variables. So if your factor has a variable in it, then you can set that equal to 0. This you cannot set to 0. So the only factors here, the only solutions for this would be x equals 5 and negative 7. This one is a variable, so you can include it as 0, 5, and negative 7. But you can't change the value of 2 to 0 just because you want to set something equal to 0. That doesn't work. And when you do that, you get 2 is equal to 0. Well, it's not equal to 0. So there's no point in even trying that one. That should be obvious to all of you. You should be able to see 2 is not equal to 0, so you can't even try that one. But it is worth saying just for the sake of going ahead and saying it out loud so that you don't have that question later on, what do I do with the 2? How do I handle that? You ignore it. That is how you handle that. You only worry about the factors that have a variable whenever we go to solve these types of problems. All right, and that is all I have for lesson 38. I will see you guys in lesson 39.